Okay, everybody, here we have the gas law skill sheet notes. I'm not going to talk too much about this first page, but you can see what the definitions are. The units for pressure, though, millimeters of mercury, we're talking about these right here. Millimeters of mercury, atmospheres, PSI is pounds per square inch, kPa is kilopascals, pascals, and torr. We can talk about those specific units later if you need to. Temperature, degrees Celsius, and Kelvin. How do you convert from degrees Celsius to Kelvin? That is your temperature in degrees C plus 273. And to convert back from Kelvin to degrees Celsius, you subtract 273 from that. Absolute zero is 0 degrees Kelvin. That's also the same thing as saying minus 273 degrees C. That's where all motion stops. Okay. Converting temperature. Using those conversions above, you can convert these temperatures. I also drew in for you representations of solids, liquids, and gases and how close the particles are to each other. Solids are not compressible. Liquids are compressible to a bit. But for the general purposes, we're going to say that liquids are not compressible. It's just way too small of an amount. And gases are very compressible. So you can look at this table over here and determine what is what for what state of matter, solid, liquid, or gas. Okay, getting down to 4 parts of kinetic molecular theory. The first part, our molecules are constantly moving, almost a zero volume. They're very, very small. Almost a zero what's called intermolecular forces. If you haven't understood what those are, we can go back and look at those. Perfectly elastic collisions. That means there's no lost energy at all. The E stands for energy. I'm doing a lot more abbreviating for all of you. In case you can hear my dog barking in the background. Okay, gas law formulas. Avogadro's law. That equals volumes of gases at the same temperature and pressure where it contain an equal number of molecules. So 1 mole of any gas at standard temperature and pressure will occupy a volume of 22.4 liters. Okay. First law that we talked about when you weren't here was Boyle's law. And that means at a constant temperature, volume of a gas will increase as the pressure will decrease. That's an indirect relationship. And we showed the graph of that down below. And I just wanted to show you that as the pressure increases, volume will decrease. As the pressure decreases, the volume will increase. The equation for Boyle's law is this. The initial pressure times the initial volume equals the final pressure times the final volume. And here's the graph for it showing an indirect relationship when it's curved like that. Second one is Charles' law. At a constant pressure, the volume will increase as the temperature increases. That's a direct relationship. And that's shown with a straight line like this. Volume along the y-axis and temperature along the x-axis. Okay. Ideal gas law. We're going to get to that tomorrow. Dalton's law, partial pressures. The total pressure of a system is the sum of all the smaller pressures. And we practiced that in the classroom. If you need me to do that for you sometime, I will. But I got it below. Here we go. Which of the following gases will diffuse faster in number 1? Oxygen or neon or carbon dioxide and ammonia. The way you figure that out is by looking at the molecular mass of all of those. The lighter molecular mass will diffuse faster, will move through the air faster than the other one. The heavier ones will move slower. So we're going to go to number 1 down here. If you're given partial pressures of gas mix, then you can figure out the total pressure. But here we have a total pressure of 700 millimeters of mercury with partial pressures of helium being 459. And you're trying to find the partial pressure of hydrogen gas. Set up your problem like you see it. 700 millimeters of mercury is your total. You have 459 millimeters of mercury as a partial gas of helium. And you're trying to find the partial pressure of hydrogen. Simply subtract the helium partial pressure from the total pressure, and that'll give you the partial pressure of mercury. total pressure is just a sum of all the smaller pressures. So if you're trying to find the total pressure, like in number 2, then add up all the smaller partial pressures, and that'll give you your total. Okay. Boyle's law, initial pressure times initial volume equals the final pressure times the final volume. If you can identify what your initial pressure and your initial volume is, and your final pressure, like in number 1, then you can set up your problem like you see. We're solving for the final volume, V2. So it's going to end up being 99 times 300 divided by 188. And that'll give you 158 milliliters for your final volume. Same kind of idea goes for the second problem. Everything is going to be multiplying the two top numbers together and dividing by another number. You're trying to get the variable, whatever you're trying to find, by itself. So, second one, we have 0.988 times 1 divided by 2, and that gives me 0.494 atmospheres. Charles' law is the last law we're going to look at here tonight. All temperatures must be in Kelvin. So you have to convert from degrees Celsius to Kelvin, and I've given you the conversions again. In Charles' law, you are cross-multiplying. So as you can see what I have here, I set up my problem like so, and I just substituted the values in. And so I cross-multiply 362 times 112, and I divide by the remaining value. When I do that, that gives me an answer. But here, they're asking me for what Celsius temperature will arise. And the thing you have to do, since your answer is in Kelvin, is subtract 273 from it to get your answer in degrees Celsius. And in number 2, we have set the problem again according to what Charles' law looks like. We're solving for the second volume. And so we're going to cross-multiply our values again and divide by the value left over, and we get our subsequent answer, 2.58 liters. I know this is kind of quick, but I know that you can play this back and kind of look through it a little bit, so I hope this helps. Let me know tomorrow if you have any issues. Thanks.